Hello everyone. Today we will see about one topic from EC 8701 Antrason Microwave Engineering, unit number 4, passive and active microwave devices, which is unit this is the syllabus. We will see about one topic called directional coupler. It's an important one. Directional coupler is a four-port device, right? It's mainly used to couple a couple of power of couple of known power into another port. If you are going to transfer from one port to another port, means it's going to couple a small portion of power from one port to another port, right? You have to wavegates, primary wavegates, secondary wavegates. We will see one by one, and it can be designed to measure incident and reflected power SWR values, and it's going to put a path to receiver or perform a disable operations, right? This is the directional coupler. Now we have primary wavegate, secondary wavegate. So this one is secondary wavegate, this one is primary wavegate, and if you are going to transfer the power from primary wavegate, means no amount of power will be coupled to secondary wavegate also. It's a unidirectional one. And properties, if you are going to discuss properties, means a portion of power traveling from port 1 to port 2 coupled to port 2 port 4 but not port 3. If we are going to transfer from primary wavegate from port 1 to port, means a small amount of power will be coupled to port number 4, not at port number 3. Similarly, if you are going to transmitting from port 2 to port 1, means it will be coupled to port 3, not at port 4. Like we can say the properties, and this is the wavegate port 1, port 2, port 3, port 4. And if you are going to transmit port 1 to port, means port 2, means known amount of power will be coupled to port 4, not at port 3, right? PI is the incident power, PR is the received power, PF is the forward coupled power, and PB is the back power, which is given here. And the performance of the directional coupler is mainly depends on these three parameters: coupling factor, directivity, and isolation. Coupling factor is nothing but how it's going to have a coupling factor of a directional coupler is defined as the ratio of incident power PI to the forward power PF, right? It's going to return as PI divided by PF. And directivity is nothing but it is given in terms of PF by PB. It's the ratio between PF divided by PB. And also the isolation is nothing but PI divided by PB. All the values are in terms of a decibel. And types of directional coupler: 2-hole directional coupler, 4-hole directional coupler, reverse coupling directional coupler, and penta-hole directional coupler we are having. And if we are going to discuss about 2-hole directional coupler, means we have a directional coupler only we have 2 holes. The distance between 2 holes will be lambda g by 4, where lambda g is greater wavelength. And this is the example for 2-hole directional coupler. We have primary wavegate, secondary wavegate. We have only 2 holes between the directional coupler: port 1, port 2, port 3, and port 4. And the spacing between the two holes will be in the odd number of lambda g by 4, 2n plus 1 into lambda g by 4. And the coupling is given as minus 20 log 2 into modulus of BF. And we can derive the S matrix for directional coupler. Directional coupler for 4-port network is the 4x4 matrix, because the directional coupler having 4 ports, so it is 4x4 matrix. S is equal to S11, S22, S13, S14, S21, S22, S23, S24, S31, S32, S33, S34, and S41, S42, S43, and S44. And if all the 4 ports are matchly terminated, means we can write the diagonal elements value will be 0. So this corner elements value will be 0. For S11, S22, S33, S44 values will be 0. And based on the symmetry property, we can write Sij is equal to Sji. We can write S12 is equal to S21, S23 is equal to S32, and S13 is equal to S31, S24 is equal to S42, S34 is equal to S43, and S41 is equal to S14. And there is no coupling between port 1 and port 3. Already we told port 1 to port 2, and it is coupled with port number 4, not at port number 3. So there is no coupling between port 1 and 3. So we can write the value S13 is equal to S31 is equal to 0. Similarly, there is no coupling between port 2 and port 4. And if you are going to transmitting from port 2 to port 1, means it will be coupled at port number 3 only, not at port number 4. So S24 is equal to S42 is equal to 0, and we can substitute these values here in this matrix. Here the diagonal value will be 0, the remaining values will be represents there is no coupling, and this is the symmetry matrix values. S2 will be replaced by S12, and S32 will be replaced by S23, and S14 will be replaced by S14, and S43 will be replaced in terms of S34. And for complex conjugate multiplication, we can get the unitary matrix. So we can write this equation, and we can write the R1 C1, R2 C2, R3 C3, R1 and C1. We can write the value R1 C1, R2 C2, R3 C3, and R1 C3. So this is the unitary property, and this one is the 0 property. And comparing equation number 1 and 7 and 8, we can write the S1 is modulus S12 square plus S14 square is equal to S12 square, S23 square. So we can cancel S1, we can write S1, S14, S1, S23, S1, S12 gets cancelled, remaining S14 is equal to S23. And similarly, if we are going to compare these two equations, we can cancel S23, S23, and we can write S14 is S12 is equal to S34. And let us assume real part or imaginary part value. For positive it is given as P, and for negative it is given as Q.